Hello, everyone. This module is going to introduce to database management systems. In this module, we are going to look at the database models in query language, a few of useful operations, and finally, we'll look at the security issues on databases. Database is one of the most powerful application developed in computer platform. It has been developed for many decades. If we do not have a database model, then we probably have a flat database, flat file, right? So we'll look at in the first module of this database, we'll look at database models, starting from flat database. And then historically, after that, we have a network database model and hierarchical databases up until mid-1970s. And then database has been advanced technically and improves its performance and efficiency by having relational databases. And also, when we have a relational databases, we have a very, very easy and useful database user interface language. We call that SQL, also known as SQL. So we call a relational database as a real formal database technologies. Although it has very, very useful, many useful features of dealing massive data and serving the data to user request, but it has some drawbacks. So that the database community has tried to develop a new concept. We call that object-oriented databases. It started from mid-1980s. And in mid-1980s, although database communities discussed a lot about object-oriented databases, yet there is no programming languages formally developed. So database community started discussion about object-oriented databases in mid-1980s. And the first formal language of object orientation is announced in 1995, mid-1990s. So there is a 10-year gap. Okay, we call that Java. When we discuss about object-oriented databases, it has a strong future that outperforms relational databases. The strongest feature of relational object-oriented databases is modeling issues. In object orientation, we can model the complexity of a real world very, very efficiently. We don't need to define the complex objects in simple database table. Simple database table is the key component of relational databases. And therefore, that is a part of drawbacks of relational databases. Even so, even object-oriented databases have very strong features in modeling. It has also drawbacks. It has no simple and powerful query languages. The query languages in relational database, SQL, is very, very powerful and very easy to learn. But in object-oriented database, because its database itself is very complicated, there's no simple language that is invented for about 10 years or more. And after that, database community looked at, hey, why don't we combine the strong feature of a relational database and the strong feature of object-oriented database together to produce a new database model. We call that object relational databases. Object relational databases. All right. So that is the combinations of a relational database and object-oriented databases. So put together, we call that ORDB. Object relational databases. So all a little bit of details of these issues discussed in this first module of databases. Okay. After this, we'll look at the query language, so-called SQL, structured query language. Okay. The first query language has been developed in and standardized in early 1970s. After that, evolves to include more features of databases. So we have a lot of the language development progress. Even so, basically there are two languages available: data definition and data manipulation language. In this DDL language, we can define database tables, we can construct index and whatsoever. And the manipulation language enables us to access databases. Okay. And then there is other very useful language called the administration language. There are many different commercial databases available, right? Many decades ago, the IBM developed the DB2, but it's almost obsolete. After that, many languages developed, many commercial products. Infomix is one of the leading ones in the commercial side, and in academia, there is also products developed from UC Berkeley that is called Ingress, right? And then this Ingress is migrated to Postgres, and Postgres is also one of commercial products. Meanwhile, there is a Oracle. This is one of the most powerful and highly secured database management systems. And there is also a freeware of DBMS. One of a relatively good freeware database is MySQL. MySQL, right? So this one is originally developed by Sun Microsystems. Now it is acquired by Oracle, so MySQL is part of Oracle products. And another database in this commercial sector, there's a Microsoft DBMS, okay, SQL Server. The most widely used DBMS is not really database packages, but it's a simple implementation, but widely used. The most popular ones is SQLite. Why it is most popular? It's because it's a lightweight database engine. I would not say it is an engine, but anyway, it is an implementation. Because of the size, because it is free, can be embedded in many systems. Any small electronic systems where data needs to be stored and retrieved efficiently, then SQLite is used. Example for that is, for example, almost all electronic appliances uses SQLite. Almost all smartphones, Android phones or Apple phones, iPhones included SQLites. So almost all small devices uses SQLite, and it's free and simple. Although it does not maintain, for example, security management is missing almost all in SQLite. Of course, SQLite doesn't do much about transaction management. All right, so it is not really good for any commercial implementation, but and also it is not good for distributed processing, but a single local processing for small domain is very useful. All right, and then we'll look at database operations. There are many operations available, but we will look at only those 4 cases as an example. One of the strong features is indexing. Okay, although we have multiple tables in relational databases. By the way, we'll look at RDB from SQL. Okay, otherwise, here we will look at RDB only, not ORDB or not ORDB. We'll look at RDB. ORDB employs the basic features of SQL, but advanced a little more toward object orientation. RDB has base tables. Okay, we call that base tables. This is base tables. Tables are, for example, when you insert new records to a table, then records are stored in the order of insertion. But when when you want to access, your access is not necessarily search through in the same way of insertion. All right. And then user request is not only search a table by one particular attributes, but it could be any within that table. So many cases we need to improve the SQL performance. Then we need to look at indexing. Indexing is some of the external structure where it can serve user request. And we'll look at inferencing, aggregations, polyinstantiations very quick in this module. So expect to learn something interesting topics. Okay. Finally, we'll look at cybersecurity issues. As you may know, there is a CIA principles. So we'll look at how these CIA principles are available in relational databases. And therefore, we will look at vulnerabilities. One of very popular vulnerability is SQL injection. Okay. So when you express SQL to avoid empty return, but if you want to access the inside the table and gain some data from a table, then you can tweak a little bit, and therefore, unless it is detected, it can be processed. SQL injection. Okay. So another one is polyinstantiation to serve user request with respect to the level of security that can be on both object side and user side. This can be very popular in military, for example. So if you have a top secret clearance, then because you have that level of security, you have an access to top secret objects. So that is a very simple principle. Okay. And as a concluding remarks, although we try to cover within this limited time space as much as we can, but definitely a lot of things missing. But this one is a good introduction. So with this introductory modules, I want you to expand and extend more, and also when you work on cybersecurity, don't forget the technology advancement in databases. All right. So from next module of this database will be the database modules. All right. This is the end.